right, everybody, let's get started on our homework for lesson 67. I'm just going to go ahead and set up my paper here so you can see that okay. And lesson 67, I've got 17 problems, 1 through 10, 15 A and B, 19 to 22, and, and 25. Okay, I'm just going to take a quick little peek, make sure that that paper is lined up and you can see that. Yep. Okay, so here we go. Let's start with number 1. We're going to find the product of 2b minus 3 squared. Okay, 2b minus 3 squared. Now, if we remember, when I have a special product rule for this, right? So if I've got 2b minus 3 times 2b minus 3, I'm going to end up with the first two terms squared minus 2 times whatever these guys are multiplied by each other, plus whatever the terms are multiplied at the end. It's okay if we don't remember that. We can do regular old distribution, which we like to remember by the acronym FOIL, right? First, outer, inner, last. So let's do that. 2b times 2b, those are the first terms. I end up with 2 times 2 is 4, and b times b is b squared. All right, I'm on to the outer terms, 2b and negative 3, which gives me negative 6b. The inner terms, negative 3 times 2b is another negative 6b. And negative 3 times negative 3 is positive 9. I've got like terms right in the middle, so I'm going to combine them before I give my final answer. So I've got 4b squared minus 12b, because minus 6 is minus 12, plus 9. That is my answer. 4b squared minus 12b plus 9. Great. On to number 2. Oh, this one's fun. It gets to start with a negative term. Good. Negative b cubed times 5, and we're going to square it, which means that I need to multiply this binomial by itself. Right? Same process. So negative b cubed times negative b cubed. Remember, when I multiply exponents, I add them, so I know it's some form of b to the 6th, right? And since it's negative b times negative b, that's going to give me a positive b to the 6th. 5 times negative b cubed is minus 5b cubed. 5 times negative b cubed, I'm on the these outer terms right now, right, is another negative 5b cubed, and 5 times 5 is 25. Again, I used that FOIL method here. Now I need to combine these terms because they're like terms, same variable raised to the same degree. Okay, so b to the 6th minus 5b cubed is going to give me a total of minus 10b cubed plus 25. I bet you guys are really getting the hang of this now. I can't wait to see how well you are handling the multiplication of polynomials. Okay, here we go. Cubed plus 25. Number 3, move this up. Okay. Number 3. Awesome. We get to simplify some radicals. So we're going to take the square root of 25 x to the 4th. Some of you might be able to see immediately what the answer to this is. If we remember, okay, I could break this up and write it as the square root of 25 times the square root of x to the 4th. I could even go a step further if I wanted to and write it as the square root of 25 times the square root of x squared times the square root of x squared. Since I know that x squared times x squared is going to give me x to the 4th, then it's quite easy. I know the square root of 25 is 5, square root of x squared is x, and the square root of x squared is x. So that gives me 2 of them all together, and this is my answer. Okay, 5x squared is my answer. That would be a great way to show your work on a test. I could have looked at this, right? Just kind of looked at it and gone, I know that the square root of 25 is 5, and I know that the square root of x to the 4th is x squared, because I know that x squared times x squared equals x to the 4th. Okay, so that's another way that I can just make sure I'm thinking through that process as well, and then I can show my thoughts as I just kind of jot down my own thought process through simplifying that radical. All right, in the next one, the square root of 144, I like that number, x to the 6th y. Looking at this, as I'm just thinking, I already know what the square root of of 144 is, right? When I look at this x to the 6th, I'm looking at it in my head right now as 3 pairs of x squareds. An x squared, x squared, x squared. I already know that this little y, I don't get to break him out of this radical, right? He's got to stay part of the radicand because there's only one of them, and without a pair, he doesn't get. I can't spring him loose. Okay, so I could rewrite this whole entire thing, and if it's helpful, you could see it that way as the square root of 144 times the square root of x to the 6th, right? But I'm just going to write it this way: x squared times x squared times x squared, because I know that that's how I break up that x to the 6th. Remember when I multiply exponents? Okay, I add them times the square root of y. Now this guy, you can see, he's going to have to stay in there. But all of these are coming out. I get to break them all out. So the square root of 144 is 12. The square root of x squared is x. Square root of x squared is x. The square root of x squared is x. The square root of y is the square root of y. Okay, when I do the final simplification here, since I've got 3 x's, I end up with 12x cubed times the square root of y. And that is the answer. Okay. If you hear our little cat, Pesci, crying at the door, it's because she is. And she's going to have to stay out there. Okay. On we go to number 5. Turn the page. Simplify the rational expression 3x over y squared plus xy to the negative 2 if possible. First thing I want to deal with, personally, when I see something like this, I want to deal with those negative exponents first. So I'm going to rewrite this with the x so that I have no negative exponents. 3x over y squared plus this guy here, x stays where it is because that's just an implied 1, a positive 1. Y to the negative 2 means I need to flip positions. Check that out. I've got common denominators now, which means I can add these. Denominator comes straight across, and now I can add right across those numerators. 3x plus x is 4 x's. And that's my answer. That's as simple as I can make that one. So 4x over y squared is my answer. Great. All right, number 6. In 3 hours, James read 18 pages of his history book. In 4 hours, he read 21 pages. Write the equation of the line that passes through the 2 points that represent the data in the problem. Use the equation to predict how many pages James will read in 6 hours. So this is a 2-part answer. All right, guys, they asked me to find 2 different things. First, the equation of the line that passes through 2 points. Okay? So, if he read, here's the points that they gave us, right? In 3 hours, James read 18 pages. That's point 1. In 4 hours, James read 21 pages. Okay. I know, right? I know how to find slope when I've got 2 points. I remember that m equals y2 minus y1 over x2 minus x1. Just keep them consistent. So we're going to call this x1, we're going to call that y1, we're going to call this x2 and y2. So let's put our values in. So I've got y2, 21, minus y1, which is 18, over x2, 4, minus x1, which is 3. 18, 19, 20, 21 is 3. 21 minus 18 is 3. 4 minus 3 is 1. Right? Okay, so now that I've got, let's see, make sure that I did that right, x2 minus x1. Write an equation of the line that passes through the 2 points that represent the data in the problem. Okay, so now I know that I've got that slope, right? Okay, 4 hours, 021 pages. The equation of the line passes through the 2 points, represent the data. Use the equation to predict how many pages James will read in 6 hours. So I don't have an equation yet, but I do have a slope, and I've got 2 sets of points on the line. So now I need to take my slope and I need to feed it back in to my y equals mx plus b, right? Okay. Or actually, you know what, guys? I guess I could just go ahead and use my my point slope formula instead. Let's do that instead. You could do this either way, but let's go ahead and use our point slope formula instead, since I've got a slope and I'm planning on just using 1 point. So do you guys remember what that is? So that's my y minus y1 equals m times x minus x1. x1 and y1 are these points right here. Remember, you leave this x and y alone, and I put my slope in here. So this is going to be y minus 18 equals 3 times x minus 3. Okay? I need to do a little bit of moving some terms around here so that I can end up with an equation. I'm going to go ahead and write this equation. And I guess I could leave it this way, but I'm going to write it in my y equals mx plus b format. All right, so y minus 18 equals, let's distribute 3x. 3 times negative 3 is negative 9. I'm going to add 18 here and add 18 here, and I'm going to end up with y equals 3x plus 9. Okay. How many pages will James have read after he reads for 6 hours? So now I need to take, so this is the answer to letter A, right? So for 6A, my equation is 3x, oh gosh, I forgot to put y equals, sorry. For 6A, I've got y equals 3x plus 9. For 6B, that's the second part of the answer. They're asking me how many pages, estimate how many pages will James have read after, what was it again? 6 hours. So I need to go ahead and put in 6 for x. So I've got 3 times 6 plus 9. So y equals 18 plus 9. And when I do that addition, I get y equals 27. So the answer for letter B is that James will have read 27 pages. Fantastic. Okay, let's keep on going. Number 7. Solve the inequality. Z minus 3 is greater than or equal to 10. I like those addition or subtraction ones because I know that this guy is just going to stay the way he is, and I can move terms around just like I would with an equal sign. So that means that I move it off of this side here. Z is by itself. Z is greater than or equal to 13. I did not need to graph it, didn't ask me to, so I'm not gonna. Z is greater than or equal to 13. Number 8. Z minus 5 is less than, oh, sorry, I misread that. Z minus 5 is less than negative 2. Okay, so I'm going to add 5 here, and I'll add 5 over here, and I'll end up with Z is less than 3. That's it. Don't you love it when they're easy like that? All right. Number 9. The stem and leaf plot shows the number of cards each member of a baseball card enthusiast club has. What is the mode of the data? So all I need to remember for mode is that mode is the most frequent value or values. If there's more than one, there can be more than one mode. So as I look at the stem, I already know that it's not going to be here in the 300s, in the well, I don't know which one it's going to be. I know it's not going to be in 309. There's only one value in there, right? And I can, as I look at the 33 stem and the 34 stem, I don't see any repeated values. However, take a look at that 31. The leaves for 31, which represent 310 there, right? Okay, are 1, 4, 5, 7, 7. So I have at least 2. I've got 317 twice. I've got, look at that 32 stem right there. I've got 4 leaves, right? So that means I have 324 3 times. So far that's winning for mode, right? Because there's 3 instances there that number shows up. Oh my, and look at my 35 stem. I've got 3 6s in my leaves. That means I have 2 modes. Okay, so I've got 324 shows up 3 times, and 356 shows up 3 times. So they are tied for the winner of mode. All right, so I've got 2 values, 324 and 356. Those are the modes. And we are on to number 10. 2 subway trains run through a station. One train goes through the station every 44 minutes. The other goes through the station every 28 minutes. If they just went through the station at the same time, how many minutes will it be until the next time they're both at the station at the same time? All right, we got to find the least common multiple of 44. Is that right? Every 44 minutes? Yeah. And 28. So let's work through our prime factorization. 4 times 11. I can break 4 down. And that's as factored as I can get that guy. 7 and 4, right? Multiplied together make 28. I can break the 4 down into 2 and a 2. 7's a prime number, so there are the prime factors. 2 is represented twice in each of these numbers, so I need to write that down twice. I've got 1 7 and 1 11. I'm going to use my calculator. Oops. Okay, and multiply 2 times 7 times 11. And I get 308. So that is my answer here for number 10, 308 minutes. Okay, that will be the next time that both are at the station at the same time. All right, let's go on now to number 15. And we've got 15A and B, which is all of 15. That's all it's got. Find the volume of a toy building block that is in the shape of a cube with the side length of 2x plus 2 inches. So I've got a cube. All right, so I've got my little cube here, and I want to remember that the volume, formula for volume of a cube, you guys remember this, is length times width times height. And for volume, right, of a shape like this, and the special thing about a cube is that all of the side lengths are the same. So because I know that one side length is 2x plus 2, they all are. So I need to multiply, right, to find, what is it asking me to do here? Find the volume. So the first thing that it asks me to do here for letter A is to find the area of the base. So if I'm finding just the area of the base, I'm just finding the area of this square right here. So that means I'm going to multiply 2x plus 2, one side length, by one more side length right here. And I'll get the area of just the base. Right, guys? Okay, so I'll find that total product. So that's basically the length and the width. That'll check those two off. If I remember my special products rules, I will remember that the product of a plus b times a plus b, you guys remember this, is going to be a squared plus 2ab plus b squared. So if I just follow that special product rule, I could see that I'm going to get this term squared, which is 4x squared, plus twice whatever this is. So 2 times 2x is 4x, right? And I've got I'm going to multiply that by 2, so I've got 8x. And then 2 times 2, because that's my b squared, is 4. Now, if I had wanted to just go ahead and do FOIL, that would have worked also. You don't have to remember this. You could also do your regular distribution, which is multiply the first 2 terms, multiply the outer terms, the inner terms, and then the last terms. You're still going to get this. So that's the answer to 15a. That's the area. The area of the base is 4x squared plus 8x plus 4. Now, to find the full volume, though, I need to multiply it by the height. So I can take this whole entire thing and multiply it by one more of them in order to get the volume. Okay, so there's the height, and now I need to multiply it by this whole mess. Now, I can't use FOIL. I've got to do regular distribution. So I got to take this term, and I'm going to multiply it by each term in the trinomial. So let's do the first one first. 2x times 4x squared is 8x cubed. 2x times plus 8x is plus positive 16x squared. 2x times 4 is 8x. All right, now I'm going to distribute these. Okay, so 2 times positive 4x squared is going to be positive 8x squared. 2 times 8x is plus 16x, not x squared, because there's just one x here. And 2 times 4 is 8. Now, do I have any like terms? Anything I can combine? Because I've got a little pencil, colored pencil here, I think I'm going to circle my like terms. So I've got an x squared right here. Any more? Yep, and one right here. And they're both positive. And no other x cubes, no other constants, but I do have a positive 8x and a positive 16x. Okay, now let me just go ahead and write these in order. So I'm going to leave that 8x cubed alone. I'm going to deal with my x squareds next. So I've got plus 16x plus plus 16x squared plus 8x squared. So altogether, that's going to give me 24 of those guys. All right, so I took care of those. I took care of that. I have an 8x and a 16x, so I can combine those, and they're still just x's, right? But now instead of 16 of them or 8 of them, I put those together and I've got 24 of them. All right, and I have the 8. This is the volume of our cube. So if I was going to write all of that out again, x cubed plus 24x squared plus, I'm going to run out of room, guys, x plus 8. I should have just gone like this. Here it is, because it's easier to read over here. Okay, but either way. All right, we are on now to number 19. And we're getting close to being done with this homework assignment. If an equation is multiplied by a number, a system of equations is formed that has infinitely many solutions. Classify the system formed by adding a number to a given equation. So what they mean is this. If I've got f of x equals x, or y equals x, remember these are the same, and I add a number to that equation so that it becomes y equals whatever, x plus 3 or y equals x plus 5. We remember this, guys, that y equals x, that parent graph, or oh gosh, I can't draw a straight line. F of x equals x, because they're the same thing, goes through that origin point right about there. If I could draw straight lines, it'd be better, but anyway. Y equals x plus 3 just shifts it up, 1, 2, 3. Just we're going to pretend like we have. Okay, so it's going to go through right here, same slope of 1. If I wanted to graph y equals x plus 5, it's going to shift it up 5 units from the origin. Okay, 2 more units here. And I'll have a line that looks like this. These are parallel lines, right? Because I'm just taking that parent graph and I'm sliding it. It gets to shift up. So if we're going to classify this, our options are inconsistent or consistent. And you'll remember that there are 2 forms of consistent systems of equations, right? One was called independent, where there was just one answer, one point of intersection, and one is dependent, where all of the points intersect because it's the same line. This one is where they never intersect. That's the situation we have here. So the answer to this, if I were to add a number to that equation, is that this is an inconsistent system. Because the slopes are the same. Slope is the same, as long as slope is the same, and all I've got changing is that y-intercept, then I've got an inconsistent system. That's the classification. Inconsistent. All right. Great. Let's go on to number 20. Determine if the lines are parallel or perpendicular. Okay? Are they parallel or perpendicular? If they're parallel, they're going to have the same slope. If they're perpendicular, you guys remember this? If they're perpendicular, then the slope is going to be the negative reciprocal. So let's solve the system of equations and find out. So I've got y equals 3x plus 12. And I have y plus 9 equals 3x. First thing I want to do is get these two equations in the same format. I'm going to leave this one alone and manipulate this one here. So I'm going to take the 9 and move it over here to the other side, and I'm going to end up with y equals 3x minus 9. Now the question they asked me is, are the lines parallel or perpendicular? If I've got a question about lines being parallel or perpendicular, all I'm really looking at is the slope. Remember, if the slope is the same, then they're parallel. If the slope is a negative reciprocal, then they're perpendicular. In this case, 3x here, 3x here. That means that these are parallel lines. They have the same slope. All right, number 21. Just 3 problems left. Solve each system of linear equations. I hope you guys are loving doing this now. I think this is pretty fun. If you're a puzzle person, this is a puzzle kind of thing, right? Because we have so many options now of how to solve systems of equations. But we know that with systems of equations, we're looking for an ordered pair as a solution, okay? So I've got 2x here and 2x here, but they're the same sign. So if I want to combine these, if I want to solve by combining, then I want to change the signs to one of these equations so that the x, I could solve this by elimination. That's what I'm going to do. I'm going to change the bottom one because of this big, huge 47 right here. I want that to be positive, all right? So I'm going to multiply this entire thing by -1, leave the top alone, 2x minus 3y equals -17. Change the signs, minus 2x. As long as you change them all, then you keep what's on either side of the equal sign, right? Consistent. So this becomes, why did I multiply that by 2? Goodness, silly. I'm just changing the sign, okay? Plus 9y. I'm glad I figured that out now. Okay, plus 47. All right, now I can combine these. So if I've got basically 47 minus 17 here, right? Minus 17 plus 47, I'm going to end up with 30 left over. This goes away, 2x minus 2x is no x's. And minus 3y plus 9y is going to give me a total of positive 6y's. Divide by 6, divide this side by 6, and I end up with y equals 5. Cool. I am not done yet. Okay, because all I have right now, so far I've got half of an answer. I have the y value, but I need the x. So to get x, I'm going to take that y equals 5, I'm going to stick it back in that top equation so that I can solve for x. 2x minus 3, remember y over here we found out was 5, equals -17. 2x minus 15 equals -17. Add the 15, get rid of it on this side and move it over here. And I end up with 2x equals -2, because -17 plus 15 is -2. I'm going to divide by 2, and I end up with x equals -1. So there's my x value. My solution is the ordered pair, -1, 5. Alrighty, I think we've got 2 problems left, number 21 and number 25, and then we'll be all done. So here's 21.